Oh, what's up, dudes? Alright, so I had to take the day off yesterday from coding because I had to, my computer is ancient. It's, it, many of the components are dinosaurs, even though I upgraded from, from the fucking Cretaceous era to the Pleistocene or whatever. I got a 1,000-year-old dinosaur, switched it out for like a 100-year-old dinosaur, and it doesn't work sometimes. The motherboard like shorts out. Well, I fixed that issue, but I just decided it was time for me to make an upgrade because I have computer issues sometimes, and I was like, you know what, I'm tired of dealing with computer issues. I've been putting it off for a long time, so I just went ahead and um, instead of like fixing it immediately and resetting the BIOS and all that, I was just like, you know what, I'm just getting a new motherboard, I'm getting a new CPU, a new graphics card, and new RAM. So I went ahead and did that yesterday. It took up most of my day, but I ended up ordering everything, so it should be here soon. And I'll be switching that over, and I'll have a nice upgraded computer, and I won't be dealing with, instability issues and crashes and whatever like I have to deal with sometimes. So that's why yesterday was not a thing, but today's a new day. So here we go. Let's pick up where we left off. Day before yesterday, that was we were continuing the implementation of the database in the client refactor. We tested all the changes and verified correct syntax, etc. etc. Let's go over here, and I think I'm going to hold off on doing any more SQLite testing. I just don't have it in me right now. I don't feel like doing it, so I'm not going to do it. You know what I was thinking about getting? I have a 27-inch monitor. It's not like huge, but it's not small. It's a good size monitor. I was thinking about getting a different monitor. Then I found out they have these like arms. It's like clamps to your desk, and it's like a swivel. It connects to the back of the monitor, and you can kind of like, you can make your monitor be closer to your face. For like if I'm gaming or something, to make it more immersive. Now when I'm coding, I like to be able to see the entire screen without having to like do this number here. But yeah, I was like, I might get one of those swivel arm things. We'll see. I'm like switching up my setup here. I'm trying to think that'll help me too to be more motivated with programming and just in my workspace in general. Having like a new setup might help me, uh, you know, get the ball rolling when I'm feeling burnt out sometimes. It's always nice, if you get something new, it spark your interest again. Alright, so we're at line 360 in client refactor. We had reviewed up until this timer set here. Stand that bad boy up. Why is it upside down? There we go. Alright, timer set. And let's do this. Alright, so we had reviewed all the way up until this point. We have, we're in this section here, which is where we have determined if it's a reconnect, and now we are choosing to start a new game, and we're connecting to the remote server. So we're not going to be playing locally couch co-op. We're going to be playing online against another client that's also connected to the server. So in this case, we would do con equals n connect local to false. Then we have client ID, game ID equal to get client and game ID connection. Okay, so we get the client and game ID. And does this internally deserialize? Now that I don't remember. I'm pretty sure it does. Let's go ahead and check this. So it decodes it. And then it converts it to integer. Because it was a string. And why is it a string? Oh, okay. Will always be 10 bytes as one concatenated string consisting of client ID plus a break character plus game ID. I'm not gonna change that. We're gonna leave that as it is. Yeah, we'll leave that as it is. So yeah, dude, I'm upgrading the dinosaur, bro. It feels nice, honestly. I was excited to do it. You know, I was used to grew up pretty poor, and I learned to make my money stretch, you know, and to do without. But I think I kind of lean towards the doing without side for too long, and I'm ready to not lean so far to that. And to actually, you know, make sure I have a stable setup. I don't to save a few dollars, and apparently I'm disconnecting. I've disconnected twice so far, so I don't even know if the stream's still working. Usually if it reconnects within a couple seconds, it's still working, but I guess figure that we'll see. Let's go ahead and check. I mean, it doesn't really matter that much, but it is kind of like silly to think that I got the stream rolling and it's actually to save a few dollars. Okay, and apparently here we go. All right, so it's still going. Okay, so this does decode it, and it converts it to an integer. So it does all the work, and then it returns a tuple. Returns tuple client ID game ID. So let me just disconnect and another reconnect, and that is actually making me mad. It's pissing me off. I don't know why, because it's showing green right here. It's showing that I'm getting a good connection. That's what man. Problems with computers and just like crashes and all that, and streaming issues, pain in the ass. And there it goes, disconnected again. Okay, alright, so let's put the note here. We'll say returns tuple client ID game ID. So so we unpack it by doing client ID game ID. So this should work. I think this should work. I think we actually tested this. Did we not test this? You know what? We can do that real quick. Well, I'll finish reviewing this section and then we'll go ahead and test it. So I think this works, but I'll just put a little note here. Well, I don't know. That's actually not going to work. Well, I can't run it standalone. I would actually have to. Yeah, because I couldn't just run the client script and test this part. I could test some parts of it, but it's not going to enter into this. Like, it's not going to let me. Well, maybe it would. Well, no, because the server wouldn't be running as well. I mean, theoretically, I could just run the server and then run this script alongside it, just like I would run client. And I think that would work. I don't know. We'll have to figure that out. We'll see. Anyway, we're gonna test it one way or another, whether we do it, you know, legitimately after the refactor or prior to that. Then we have serialized client ID, which equals pickle dumps client ID, which serializes the client ID, and we're serializing it because you know, it's kind of funny because we're serializing it, and when we actually receive it, it's already well, the whole thing is serialized. Or is it not? Is it not serialized when we receive it? So it is. It's encoded. Is encoded the same as serialized? Now, you know, I want to say that I think it is. Let's see. I'm not positive, but let's ask Claude about this. Is dot encoded the same as dot pickle dot dump? Let's see. No, encode and pickle dumps are different functions with different purposes. Encode is a string method that converts a string to bytes. So it converts it to actual bytes. Specified encoding UTF-8 by default. It only works on strings and is used for text encoding. Gotcha. Okay. Pickle dump serializes Python object into a byte stream that can later be deserialized. It works on nearly any Python objects, not just strings, and preserves type, information, and structure. Encode is for text encoding only. Gotcha. Dump serializes complete Python objects. Output is encoding specific text as bytes. Dumps creates Python specific binary. Okay, so they're different. They're not the same. Code turns it into bytes. Dumps turns it into binary. It's a string. But isn't a byte stream a string of bytes? You're right about the terminology overlap, which can be confusing. Both encode and pickle produce byte objects, the bytes type in Python, but they have fundamentally different purposes and contents. It converts a text string to its raw byte representation according to a character encoding. The bytes directly correspond to the characters. Pickle dump serializes Python objects into a special binary that includes type information structure and relationship data. It say both create strings of bytes in the sense that they produce byte sequences, but name is equal to Alice, name dot encode. Gotcha. If we do name pickle, it contains Python specific metadata about the string. So if you were to print out name bytes, it would print out be Alice. But if you did pickle, it would print out this. Gotcha. Okay, so it contains Alice over here, but it's got a lot more going on. Okay, fair enough. I knew they were similar, but yeah, okay, so they're They're not the same. They're similar. The typical format contains significantly more information to enable full reconstruction of Python objects, while encode is a simpler transformation focused only on character representation. Okay, that makes sense to me. Alright, so yeah, it is encoded, but it is not serialized. And did we test this? We tested this function. Yeah, I'll just put a note here. Quite certain we tested this function and verified it does work as intended. And you know what I realized? I had my setup to where my keyboard was like far away and my monitor was like far away, and I thought it was just my keyboard switching out my keyboard that was causing me to like type slower and have more mistakes. But then I realized it was actually because it was farther away as well. So I kind of pulled everything a little closer. Made a huge difference. And I noticed it immediately when I moved it closer. I was like, man, this is so much better. So we're not going to do a SQLite test. Exit out of that. Okay, so back over here. So we can't just grab it straight up. We do have to serialize it. I was going to see if it was already serialized and we could just, you know, skip these 3 lines here since it was already serialized, but it's not. It wasn't serialized, it was encoded, which is different. So then we do serialized client ID, which is pickle dumps client ID. We do serialized game ID, we do the same thing for the game ID. Then we get a serialized tuple, which is a tuple of tuples containing the client ID as the object name. And then the serialized client ID is the blob, which is why it has to be serialized, because that's how blobs have to be serialized. They're binary large objects, which is a pickled object, essentially. Cursor execute many, and this is gonna do a internal for loop optimized to insert into the saved data table the object name and value parameter with the values unless there's a conflict, meaning that they already exist. If the client ID and game ID already exist, that means they had previously started a game, but now they're starting a new one, which is fine. So we'll put a note here. Say below line. To 1925. But we use on conflict in the case that, see, I can type so much better now. It's just so much easier. Use on conflict in the case that the player had already started the game, but wants to start a new one, having left the other game. Use on conflicts in the case that the player had already started a game and wants to start a new one. If we didn't, we would get an error scenario. True. So it does an upsert, which is an insert, but unless it exists already, then it updates. So it's an insert or update, depending on whether or not it exists already. So in this case, on conflict of the object name, meaning the object name already exists in the table, it's going to update it and it's going to set the value equal to that is the data inside of the serialized tuple, namely the serialized client ID or the serialized game ID. We verified that in testing that works 100%. Okay, so that was where we had stopped. So now we're caught back up. So then we set started game local or remote equal to remote. And I actually need to do this. Like, do I actually need to do this? That's the question I have right now. Do I need started game local or remote? Why do we have this? What was the original reason for this? Let's do Control-Shift-F on it and see if we can find more data. Let's see. In this case, we wouldn't need to receive the client ID from the server side since we would already have received it previously. We would instead assign it by loading the save file. If we had the game ID saved, that means we have the client ID saved as well since it was received prior to game ID. So this is saying if we choose to start a new game, rather if we choose to reconnect to the game, then we want to load started game local or remote to determine method of connection. Okay. Yeah, that makes sense, right? Because how else would we know if we were connected to couch co-op or to an online connection? You know, there wouldn't. I have to turn this. I don't want to hear that. I don't want to see that notification ever again because it's still working. I won't see. It's really driving me insane. So I just turn that notification off. I won't hear it anymore. Cool. So yeah, started game local or remote. Start a game local or remote to save file. Okay, yeah. So this I think we do need this. Start a game local or remote. Yeah, I think we do. Yeah, because if we connected remotely and we're reconnecting, then how do we know? Like, if we got disconnected, if the computer shut off and we got disconnected from a local couch co-op game, and then we reconnected to that game when we started back up, that data would still be in the save file. So the game state would be saved in the save file, but there would be no like way to determine if it was local or remote. And speaking of that, whenever we have a locally connected game, doesn't that mean that we need to save like both? Well, we would have to open up two clients on the same PC. So it wouldn't be like a split screen thing. It would literally be two separate client windows currently. unless we like modified for that. Now, I am not actually planning on doing that. You know, this is not really meant to be a legit. This is more just learn it to get a job, etc. Um, but I do want it to be somewhat legitimate. Um, should we add in a split screen thing local play? That would require a good bit of work because we would have to make it to where one client script handled two clients. And honestly, that is a pretty and I don't really want to do that. Not that invested in it anymore. I don't want to do that. So I think I'm gonna say no to that, and we're just gonna if they do local, they're just gonna have to run two clients and alt tab between ghetto type shit. But I'm not that invested in it, you know. It's not that serious to make it immersive and legitimate. So that answers that question. We're not going to do that. We will allow them to play locally if they want to. They just have to have two clients open. Fine. But wouldn't that mean we would have two of the same database files? Like, if it was client 1 versus client 2, we would have to have a different save file for each client. So I'll just add that in things to do. I'm glad that I caught that. We'll say local game second client second database file. Make sure we account for this. Add logic into client refactor slash client pi to ensure that whenever local game is being made, which requires two client scripts running on same machine, is being played, which requires two client scripts. The database file name is different a second client. Either that or ensure we distinguish between, well, we would want two different database files, I think, because then we would be dealing with like, well, we wouldn't necessarily be dealing with concurrency issues, but could. So distinguish between client number 1, 2 data in the singular DB file. Seems like the second DB file option would be a better / safer choice. Just from off the top of my head, it seems like a better decision. Okay, so now we have SQLite. Let's close this. We're not going to do that. Alright, so back to this. We have started game local or remote equals remote. Save started game local remote to save file. So now we're going to go ahead and save this because we do want to retain that information. Yeah, because either way, if it's local or remote, we still get a client ID and a game ID. I mean, that's still necessary. And yeah, we would have to distinguish between the two database files, or we would have to like distinguish between the client ID for client 1 and the client ID for client 2 if they were saved to the same database file. So this right here, where we save the client ID and the game ID to the database, that is necessary for reconnecting. Unique client 1 versus client 2, even on a local setup. Yeah, so we would have to distinguish between like those two different files. We would have to have a different, basically just a different save file. So that's yeah, and we do need this because we have to, whenever we go to connect, it determines whether or not we're gonna pass local equals true or local equals false. So yeah, we definitely need that. So let's go ahead and implement this save into the database. So now we'll just divvy this out and we'll put db save started game local or remote. Just put save started game remote 2db. Okay. Well, you know what? We could do this all together, right? We could also do equals remote, and then we could say serialized game local or remote equals started game local or remote pickle dumps, and there we go. So serialized game local or remote equals dumps started game local or remote. There you go. So we could add this to the tuple as well. So in this case, we would put the object name would be serial. Well, I'll just copy this because that's, we use the naming system, like the name of the object is going to be equal to the object name in the database. And then the actual blob would be the serialized game local or remote. Yeah, so there you go. We have 3 tuples now. So it's gonna execute many. It's gonna insert the object name and value. And then for this final one, it's gonna be serialized game local or remote as the object name, and then serialized game local or remote as the value, which is the pickled version of the started game note. They say not to say what you did in the code in your comment associated with the line. I think that's the good way to make sure your code is correct, because if you can write it out in plain English, you fully understand it and that you've reviewed it. Serialized game local or remote equals pickle dump start game local or remote. Yeah, so that should be correct. are connected to the remote in this case. But yeah, so it's going to save all three of those things to the database at that point. So that's already done. Alright, so we... Oh yeah, but don't we need to do commit, right? Because we don't have auto commit on. And that was something we were learning about before, and we were questioning whether or not we should have auto commit. So should we auto commit, or should we just let me ask Claude about this again. If I'm doing frequent writes and rarely reading from DB, should I enable auto commit? Frequent writes and rare reads, I generally recommend not enabling auto commit. Transaction batching is more efficient for frequent writes. When auto commit is disabled, you can batch writes into a single transaction, reduce overhead from transaction start commit operations, decrease overall input-output load on the database. Instead of auto commit, consider explicitly committing after logical groups of operations using transaction blocks with periodic commits every 1,000 records, staying per transaction. If data consistency between writes isn't critical, larger batches are better. If your writes are completely independent, smaller, more frequent commits might work. Consider your database specific. I'm using SQLite 3 on Python for an online card game. I'm trying to ensure save state persistence above performance. So shouldn't I commit almost every single time I write to every time I make a DB command, which means I could just enable auto commit to ensure we are always committing without having to type it out over and over and possibly getting to do it. If save state persistence is your absolute priority for the card game, then yes, enabling auto commit in SQLite 3 makes sense in your case. With auto commit enabled, each SQL command completes with its own implicit transaction, ensuring the changes are immediately persisted to disk. This gives you maximum data durability. Game state is saved after every operation. Simplicity, you don't need to manage transactions manually. And then 3, peace of mind, no risk of forgetting to commit. In Python's SQLite 3, auto commit is actually the default behavior. That's not true. I remember we talked about this. Unless you've explicitly started a transaction, you get auto commit by just not calling begin transaction or similar methods. Yeah, it's not actually slightly reduced performance, more disk I/O, potentially more disk fragmentation. Given that online card games typically don't have extremely high transaction volumes, these trade-offs are reasonable for prioritizing state persistence. So let me go ahead and yeah, we'll enable auto commit. And I can't remember exactly how do you enable auto commit in SQLite 3 on Python. Auto commit is actually enabled by default. You don't need to auto commit only. That's not true. Auto commit only applies when you're not inside a transaction. Then when you start a transaction, you need to commit it. Yeah, that's not actually true. Auto commit is enabled by local something. It's not default. Really right, I made a mistake. Auto commit is not the default behavior in Python 3 SQLite module. To explicitly enable auto commit, you need to set the isolation level parameter to none. That's what it was. Yeah, so we need to do con equals SQLite connect gamedb and then isolation level equal to none. Now every statement auto commits without needing con.commit. So come and execute update player set. See, now this is strange. I would think that these models, don't they learn like after the fact? So you would expect that once like you correct it, you know, like it just was wrong and then I corrected it. Now you would think it would remember that, you know, but it doesn't. Like it doesn't. It still thinks what it thought before. I made a mistake. Auto commit is not the default behavior in Python SQLite module. To explicitly enable auto commit in SQLite 3, you need to set the isolation level parameter to none. Import SQLite 3, con equals SQLite 3. Yeah, and every statement by default starts an implicit. By default, SQLite 3 in Python starts an implicit transaction statements requiring an explicit con commit to persist changes. Setting isolation level equals none is the correct way to enable auto commit for your card game save state persistence needs. Yeah, so that's what we want. We want isolation level equals none. And like, why is it called? Why is it called isolation level? Why does setting it to none cause auto commit? The parameter name, isolation level, and its behavior come from database transaction theory. Isolation level refers to how transactions interact with each other. Specifically, how changes made by one transaction are visible to others running concurrently. It's one of the ACID properties. Atomicity, consistency, isolation, durability. Why none enables auto commit? Setting isolation level equal none tells SQLite that you don't need transaction isolation at all. You don't want any transaction isolation at all. Gotcha. So that means independent transactions with multiple commands versus isolation level being none. That means you want no separation of transaction. Every command to be a transaction. Without transaction isolation, each statement executes independently and commits immediately. You don't want any transaction isolation. Without transaction isolation. That is just a weird way of phrasing that. Am I wrong here? But does that seem strange? A strange way to phrase that concept? Each statement executes independently and commits immediately after completion. The SQLite Python API designers chose this approach because when you specify an isolation level like deferred, immediate, or exclusive, you're requesting transaction behavior. When you set it to none, you're effectively saying, I don't want transaction behavior at all. Without transaction behavior, the natural default is to commit each statement individually. It's somewhat counterintuitive naming if you're not familiar with database theory, since you might expect a parameter like auto commit equal true instead. The current design reflects the database-centric perspective where transactions and isolation levels are the primary concepts. Gotcha. Isolation level equals none. So that's what we want to do. And we are going to need to test it because I don't like adding anything to the project without testing it. So let's open up SQLite testing. I'm pretty sure we had a line set up for this. Maybe we did, maybe we didn't. Limit begin transaction case when count sum average order by then else excluded commit. what is this? Oops, I just messed up the clipboard there. Alright, so let's paste that in. And this is going to be isolation level. Say isolation level test. Copy that. Get rid of it, bring it all the way up here. Where are we going up here? I would like to say we should go all the way to the top where we create the database. Yeah, because that's basically what we're doing. This is isolation level. So in this case, we would say con SQLite 3 connect game database. Yeah, so we'll have a different one. It'll be game database. Isolation level equals none, and then we're gonna do cursor. What do you call it? Game cursor equals, and we want to call this GameCon. There you go. So this was equal to GameCon.cursor. And then we want to do GameCon like a night cursor. Now we'll do game cursor dot execute. We want to create a table, so we do create table if not exists save data, and then we're gonna do object name text primary key value, and we'll just say blob. Well, how about this? We'll do value integer. We'll just call this integer instead, or we'll just call it ID. Yeah. So we have the object name and then the ID. Yeah, so there we go. We created that table. Now we're gonna do an insert into save data. We say values, and then we do question mark, and then we so now we need the object name as text, and we'll do and we'll say, let's just say game ID is equal to that's it. That's all we need right there. I think that's right. Yeah, that should be it. And now we can do, what did I hit? I hit a key. I hit the wrong key. OVR. Yeah, we don't want OVR enabled. Okay, so now this should be committed. Which means if we did game cursor dot execute select from, we'll say select ID from save data, where object name is equal to question mark, and then we'll do comma, and then we'll just say object name is equal to game ID. So we're going to select the ID, which should be 1, from the save data table, where the object name, which is the primary key, is equal to game ID. Yeah, I think that's right. I don't know if I have to put this in a tuple or not. I can't remember. And then we want to do print. What do we do? Fetch one, right? We do no. We do con fetch one. So then we would say game con fetch one. I think. Let's see. Yeah, so we say cursor. What? No, we actually say cursor fetch one. So it's not con fetch one, it's cursor fetch one. I don't know why I thought it was connection instead of cursor. Okay. So in this case, we can disable these two. And we can also disable this because we're not going to be using the cursor. We're going to be using the game cursor. Let me just make sure everything else is disabled. Now, we didn't explicitly call commit. Oh yeah. So I think that's to the bottom here. Let me try that again. Just make sure. Okay, yeah. Then we do con commit. Okay, we want to disable that commit, and we'll also disable the close there. So, and where are we at? Here we go. All right, so we have the game con equals SQLite3 connect, and we say game database, which is going to be the file, database file name, and then we say isolation level equals none. And this should put isolation level none enables auto commit. Commits implicitly after each statement. So yeah, like any insert, create, delete, modify, it's gonna commit. You don't have to commit after a select. Like, that doesn't do that. So then we have the cursor created. Then we have cursor execute create table. Exist save data object name text primary key integer. I feel like that's not right. I feel like there's something missing from that. No, that's right. If not exist, save data, and then you just put the parameters, the column names. Yeah, okay, that's actually correct. Then we do insert into save data values, game ID and 1. Then we do execute select ID from the save data table where the object name is equal to placeholder, and then close quotes, comma, and then we enter in the game ID. Now I don't know if that should be in a tuple or not, but we'll figure it out because we'll get an error if it's not correctly coded. Then we print out game cursor fetch 1, which should return a tuple consisting of the ID, but if we do it index 0, this should return the actual ID itself. And you can only select if it has been committed. Can only select what has been committed. Isn't that true? Can't you only select what has already been committed to the database? Not exactly. What you can select depends on the transaction isolation level and whether you're transaction. Same connection. Select data you've modified but haven't committed yet. These uncommitted changes are visible to queries in your own connection. This happens even without auto commit enabled. However, you can select data you've modified but uncommitted yet. However, other connections won't see your changes and decommit them. Okay, it determines how each connection sees Oh, this is where isolation level matters. It determines how each connection sees the database state relative to ongoing transactions. The only seeing committed data rule applies to separate database connections. Okay, so if isolation level is set to none, then how does that affect other connections seeing the data? When isolation level is equal to none, all changes are committed immediately, which means, okay, no explicit statement in its own. Okay, so this is good for multi-connection scenarios. Without auto-commit connection, you will continue seeing the old value. Gotcha. I see. I see. Gotcha. That makes sense. Alright, so Claude only gives you a few prompts. ChatGPT gives you way more prompts before it cuts you off. Claude only gives you a few. And I'm not gonna lie, I just prefer ChatGPT. I feel like ChatGPT is really good. Okay, so what are we doing here? Yeah, so now we can test this. Alright, so let's run this script. Do Control F5. Let's see what we get here. Incorrect number of bindings supplied. Okay, yeah, so we do have to put it inside of a tuple. You get that error if it's not the programming error, incorrect number of bindings. Yeah, that binding number error is associated with not having it inside of a tuple. Constraint failed. Save data object name. This has to be inside. Placeholders have to be inside of parentheses. Save data object name. Let's rerun it. Line 48. Select ID from save data where object name is equal to current incorrect number of bindings supplied. Okay, so how do we test this? I'm trying to think here. Save data, and then we want to select. How do we determine if something's been committed? Like, how do we verify that? All right, that I know how we do that. That's why we use select exists. It exists. Doesn't select exists. Let's see, SQLite 3. How do we verify something that's been committed? me check this actually. SQLite 3 Python, is auto commit the default setting? Auto commit in SQLite 3. Int SQLite 3 get auto commit SQLite 3. SQLite 3 get auto commit interface returns 0, non-zero or 0 if the given database connection is or is not. So if it returns 1, then it is auto commit mode. If it's 0, then it's not. Auto commit mode is on by default. Auto commit mode is disabled by a begin statement. So let's get this SQLite 3 get auto commit. Let's go over here. Do get auto commit. We got 7 more minutes left. I'm tired. I did not sleep well at all. I had to take a nap and it just didn't happen. I just wasn't sleeping right. Let's see. Let me get auto commit, but this the light. What is this? C interface? What is SQLite C interface? What is this? But I thought even without committing, you could select data that hasn't been committed. SQLite uncommitted should convert by the same connection, so you can form select query and say uncommitted should try SQLite commit. Or uncommitted change are visible within the same connection, but not from other connections. So you'd have to do select exists. But I could use select exist to verify. You can use select exist query to verify whether a record exists if the data hasn't been committed yet. Why did I use select exist before? Enable table creation. Yeah, that's fine. So that has nothing to do with committing. So what am I really wanting to check for here? I think I kind of got a little spaced out. Let me reset. So there's level connection. SQLite got it. Whoa. So I'm inserting, and then I want to see. I want to verify that it's been committed. But how do you verify if it's been committed? Okay, well, if select exists and select ID, select would show me the data that it existed even prior to a commit. But I thought I have another question. Just put this so I don't forget. Ask AI about isolation level versus auto commit in SQLite 3. Getting mixed answers. So I'm getting like, yeah, I'm getting some mixed answers here about that. I don't need a separate thing for that. So one way to verify, let's do this line. Then we're gonna say, without changing the isolation level, we're just gonna leave it as is, as the default, okay? Should be not auto commit. Should be not auto committing. So in this case, ask about this too. Ask AI about Python like of that, because that's for like C or something. I don't know. That was from the SQLite documentation, but I think it was for like some specific interface or something. C interface, not what I'm dealing with. Alright, so then we have GameCon. So we don't set the isolation level. So we want to determine if auto commit is default. If auto commit is default, then just setting it like this, we should be able to create a table, insert into the table, and then we should be able to create a new connection. Yeah, we create a new connection. So we'll say game. I think we can do it like this. I've never done this before. We'll say GameCon2 equals SQLite 3 dot connect, and then we're gonna connect to game database. Just doing the same thing. Establishes second connection to same database, and then we do, where's that select that I deleted? Let me grab it real quick. There it is. Right. So now we'll do game cursor would be game cursor 2. Or, yeah, we'll call it game cursor 2. Then we want to do GameCon2 cursor, and then we would say game cursor 2.execute. So we're using we have a second game connection to the same database. Then we have, we'll just create, we'll connect to it, separate connections here. We have GameCon, game cursor, or GameCon, GameCon2, and then game cursor 2, and then we have game cursor execute create, game cursor execute insert, and then we have game cursor 2 select, and then game cursor 2 fetch 1. Let's delete this file and just run it and see what the fuck did I just do, man. That. Let's go back here. Game DB, let's close it. Delete it rather. Back over here. We don't need this. But what we're anything extra to be enabled, then that it is deleted. So let's run this and see what happens here. Incorrect number of bindings supplied on 56. Assuming uses 1. Am I supposed to put a comma after it? Is that why? Oh, I know why. I know why. Forgot to put the comma in my tuple. Whenever you have a tuple of one object, you have to have a comma. It's a stupid rule, but it's a rule nonetheless. Gain cursor to fetch 1. None type object is not subscriptable. See if that makes any difference. I don't think that's gonna make a difference, but let's see. Okay, yeah, so we don't actually need the front. And it's actually time for breaks. I'm gonna go ahead and take a break real quick. I'll be back in a minute. Okay. Well, we're getting there. To learn. Okay, dudes, we're back. Man, that camera is so close, huh? I don't know why exactly. It's, well, I mean, I moved, I know why it is, but it didn't look that close before. But, kind of feel like it's smothering me. Anyway, let's try to do a little bit more. I am utterly exhausted, and, God, I hope I sleep good tonight. I don't know if it's anxiety or what. I have a lot going on in my life, but I go to bed on time, and I'm just haven't been falling asleep. I go to down, and I don't fall asleep. So 7 hours, which is not really enough for me, because I work out a lot and stuff. So my body's like always, kind of always in recovery mode, because I work out 6 days a week. Plus, I don't know. I'm a tired. I'm an old man type person. I get tired easily. Anyway, so let's jump back in. So we wanted to test this with the 2 cursors, but for some reason I'm getting an error here where it says untype object is not subscriptable. So I guess that means, like, I thought, oh right, because it's none. Okay, I'm an idiot. I understand now. It's working. I just can't select 75. I have something enabled. Alright, so that was creating an issue. Let's delete this file and run it again. Okay, yeah, so we get none. And that means either like I queried this incorrectly. How about this? To just verify, to be extra safe, we'll just say select all from save data. And this will literally select everything from that table, all the rows, and then I'll just do fetch all. Isn't that what it is? Yeah, fetch all. And now we run this, it should work. Right, okay, so we get an empty list here, and this list is all of the rows that it selected, and since there are no rows, that means there is no data in the save data table. And just to verify, let's verify this, because I've never really done this before. SQL Lite 3 Python, can we have multiple connections to the same DB? Yes, in SQLite you can have multiple connections to the same database file, but there are a few important details and potential issues to keep in mind. In your database, multiple connections can open the same database file, but they need to be careful about concurrent access. SQLite supports concurrent read access, but write operations are more restricted. Transactions, if one connection has an open transaction, a write operation, other connections may not be able to perform write operations until that transaction is complete. SQLite uses database locking to ensure data consistency. While SQLite allows multiple connections for reading concurrently, only one connection can write to the database at any given time. SQLite uses database level locking, not table or row level locking. Oh, so like it locks the entire, even if you're trying to read a different part of it, it locks the entire database. So while one connection is writing to the database, other connections will be locked out for writing and have to wait for the lock to release. SQLite Pragma. You can use the Pragma settings to control the behavior of multiple connections to a database. For example, Pragma Journal Mode can help control the locking behavior. Okay, I don't understand what that means. Like, I've used this. Where's pragma? I don't see pragma here. It doesn't say anything about pragma. Here we go. You can use certain pragma commands to optimize SQLite for better concurrency. Pragma journal mode equals write ahead logging allows concurrent reads and writes. Okay. Gotcha. Okay. This sets the synchronization level to allow for faster writes, but less durability. For better concurrency. Enable WL mode for both reads and writes. Multiple connection can read from the same SQLite database concurrently. Only one connection can write to the database at a time unless you use write ahead logging. You can use write ahead logging to enable better concurrency for both reads and writes. Gotcha. Okay, so we did that correctly. And now just to verify that it is working, well, this means that it's not actually defaulting to auto commit. Put this note here. Put that right there. So isolation level enables auto commit. Commits implicitly after each statement. And this should copy this. And this should say should be auto committing. So now it's going to be auto committing with this enabled. So now wait a second. Yeah. So game cursor execute insert to save data values game ID. So we use game cursor which is associated with the game con. So this one, when we did the test, is the default setting, and it's not auto committing because we did the insert from game con 1, which is set to the default setting. They're both set to the default setting. But we used game con 1 to insert into the database. We used game con 2 to select from the database. And since it's a second connection, we can't access the data because it hasn't been committed, because we're trying to access it from a different connection. That's why it returns an empty list. Let's run it again and just triple check. Yeah, so we get the same output. So we're getting consistent results here. Now we're going to change this so that it should be auto committing. So I'll just put option number 1 and it should be auto committing. Should be auto committing since isolation level equals none. And then this is going to be option number 2, which is should not be auto-committing since isolation level, well, that's a question. We're going to retrieve this data. We'll do we'll say game con or game cursor rather. We'll say game cursor. So we're going to retrieve that pragma. I'm guessing we can do game cursor.execute, and then we can say pragma and then isolation level. And that should return it. Then we can just do print. That should print it, right? So let's set it back to how it was with the default and then let's run it and see if this does work. Okay, well, oh yeah, that's not right. That's not that's not how you do that. You have to do fetch. Then we would do game cursor dot fetch one, and then we do print for that. So we're gonna print the game cursor fetch one. Let's go and delete that database file, and then we'll run this again. There we go. So it's set to none. Well, that's strange. So that is the default. Second. So why would it return? Wait, maybe it returns none if there's nothing like being. Maybe I'm doing this wrong. Okay, yeah, I'm doing this wrong. I don't understand though. So pragma isolation level, is that not pragma journal mode cursor execute, and then we do cursor fetch one at 0. Okay, maybe it's because I'm not using the, that's not why, because it wouldn't return none. It would return like a list containing none. But if it's just returning none, so it's gonna, yeah, none type object's not subscriptable. So that's not the issue here, because when we run it, the fetch one prior to any pragma, I am confused. I don't understand. It's not printing anything. Like, it's just saying game con isolation level is nothing. It doesn't say none. It's just literally nothing. Like, it doesn't exist. So it's saying deferred is actually SQLite start transaction when a write operation is done. That's not true. It's wrong. No, it's not. This is, yeah. Okay, it's just wrong on this. I don't know what else to say. Yeah, so it's not that important. Like, I got it figured out. I know how to make it work, but it's not true. Like, it's not true. It's not default to auto commit. It's not. It's just not. It's not. I'm not gonna sit here and like argue with ChatGPT. ChatGPT, if they don't know it, it doesn't know. It's not an empty string. Indicates auto commit mode. No, it doesn't. Because if it did, then it wouldn't return an empty list. Because if this is auto commit, just defaultly set, then that means this isolation level equals none should also be auto commit. Auto commit is not enabled. Deferred by default. Not none, as ChatGPT says. So this is so now when we do isolation level equals none, when we run it, now it's going to be committed, which is why it's going to show the, see, now it shows it, game ID equals 1. You can't see that because of where my screen is, can you? Well, no, the camera's on the bottom right, so yeah, you should be able to see that actually. Okay, so yeah, game ID 1. So yeah, it returns it. It does auto commit because we didn't explicitly commit. Now when we set isolation level to the default setting, I mean, we don't actually set it at all, and then we do game cursor execute, or rather you game commit. I think that's how we do it. commit. So now if we do explicitly commit, then select the other connection, it should work. Yeah, there you go. Even though isolation level has not been set, but then if we disable commit and then we rerun it, it's not auto committing. But if we do option 1, rerun it with disabled, and then when we enable commit, it should work exactly the same. There shouldn't be any different behavior. There you go. Okay, so now I know. And I want to just delete that. Well, we'll delete it. Remember, disable this if not setting isolation level. Okay, cool. So we got this all figured out. That was a lot of work. But we did it. Now isolation level and enables auto commit. If you don't explicitly set it to none, it defaults to deferred. So we need to do isolation level equals establish the database to set auto commit. We'll go up here to whenever we create the database right here. It's going to do comma isolation level equals none. It's not a string, you just say isolation level equals inside of the SQLite 3 connect. Yeah, that should can need to test this. Serialized client. That's where we at here. See many. Okay. All right. So yeah, this is where we are. If P1 game selected choice connect to local machine, then started game local. We already do client ID, game ID. Like don't. We're gonna get that either way. Does it matter? Like, couldn't we just run this once? Say, if connect to remote server is equal to, we connect to remote server, we'd say con and connect local false, and then we do else con equals and connect local true. Then we would run client ID regardless of what we chose for our selected choice, and then we'd have our started game, local or remote, and then so we could just run it once instead of twice. P1 game selected choices equal to reconnect to game. Yeah, I think that would work if we just did it like this. Copy all this and then move this to be right here. So then we would remove this, which says we'd remove these 3 lines, and then this line. Yeah, we end this. Well, actually, we would remove all this. Let me try that again and do that all at once. So I kind of messed that up. Alright. Redo that. Redo that. Alright, so from right here, we're going to copy all this, all that. The only line that we want to keep there is going to be con equals nconnect and then started game, local or remote. So now we do started game, local or remote equals remote. Then we go down here and we'll do right here, paste and go up, and there we go. So then we have P1 game, select a choice equals start new game, multiple choice function, connect to remote or connect to local, connect to the remote, con and connect local equals false because we're connecting to remote, and then we say start a game, local or remote equals remote. Either P1 game select choice connect to local, con equals and connect local equals true. Then we actually do this for local. Yeah, because we do need the, well, we need the client ID, right? We need to know like what's each client, but I guess we would have to add in code, or like we'd have to add in code here to whenever we recover the data on a local connection, that so that we would assign, I guess, like the first person to reconnect, or they would choose like which player were you? We would ask them like, were you player 1 or were you player 2? So we would have to ask them upon reconnect. I'll put this here. I'll put concerning this would have to client which player they were. Connect, i.e. player 1 or 2 to properly assign the correct DB's data. Client 1 or 2. So client ID, game ID, but we already run this, right? Yeah, we run this no matter what. But we have to have the connection first. But it doesn't matter, like, yeah, we already figured that out. Then we say start a game local remote equals local. I'll just add this to things to do, because that's a more proper place. It doesn't really belong right now. So this will be local game which client data apply after crash. And paste this in. Say, would have to ask each client which player they were when they reconnect. Since client player has diff db, each client instance will have to remember be associated with one or other form, which means player must choose she was prior to DC. Yeah, I don't know if there's a way around that, like, you know, it because since it's local and we're not doing the split screen option, we're not gonna have a way to accommodate that, if that makes sense. If it was like split screen, the left side would be, the right side would be player 2. I don't know. Maybe we could do a split screen thing. Like, maybe that wouldn't be that hard. I don't know. We would basically just have to modulize, or like, just have to we'd have to concurrently run like another client script, not necessarily another client script, but a second client game loop, which means we would just have to like put the game loop inside of a function. I don't want to add that, I'm not gonna lie. I don't want to do that. I just want to be done with this project. You understand? If you know, you know. Alright, let's go back up. So like, I'm not worried about that right now. That'll be a feature. If we add it, we add it. We're probably not. Okay, so let's see. Where were we exactly? Okay, you're writing that note about sign in proper client local connections. So we modified this to where if we choose to start a new game, whether or not it was a reconnect or not, then we allow them to determine if they're going to connect to the remote server or connect to a local machine. And if they choose to connect to the remote server, do con and connect local false, started game remote equals remote, it's local. Then we do elif selected choice is connect to local machine, then con equals nconnect local true. It's nconnect local true, right? Yeah, because they are connected to local. And then started game local remote equals local, right? And then we want to save the started game local remote to save file. So then after that, after the if elif, do client ID game ID is n get client n game ID from con, and returns tuple client ID game ID, and the con would be already set for parameters. Either way, we would get the serialized client ID, the serialized game ID. Then we would already have assigned that, so you get rid of that line. Then serialized game local remote. Okay. We serialize that as well. And then we create the serialized tuple containing all three of them and then execute them. And since we have auto commit enabled, it will auto commit because we set. Okay, and yeah, just to verify, if we did isolation level equals none like this versus isolation level did isolation level, say gamecon dot isolation level equals none, is this gonna do the same thing? So if we print it and then we do all the rest of this stuff that we wanted to do, so this should be, yeah, so basically does this do the same thing that this does, where we pass it in as a parameter versus if we set it as an attribute thereafter? Does that work? Let's see. Okay, it does work. Just to verify, we'll take this. We'll enable that, and we'll delete the file, and then we'll rerun it, and we should get the same result when we do. So you can do it either way. So we actually have three options here. This will be option 2. None, but in this case we set the isolation level equal to immediately after, like that. Okay, I'm asleep here. Let's wake back up. What are we doing? Um, I was thinking about my monitor instead of the code. Anyway, so we use on conflict here. Turn into copyrighted territory. The line we use on conflict here. We insert it into, and then so this is if we start a new game. We start a new game. Alright, then we do that. This is all good. And then, okay, now we're here. And then if we reconnect to a game, in this case we wouldn't need to get received the client ID from the server side since we would already have received it previously. We would instead assign it by loading from the save file. If we had the game ID saved, that means we would have the client ID saved as well since it's received prior to game ID. Well, they're received together now, so load started, local or remote to determine method of connection. Okay, that's right, and then get the game ID so we know which game to reconnect to. And I guess, like, for our case, I don't think it would matter. Well, for local rather, if it was local, but either way, we'll. I guess if it's local, we don't actually need the game ID. We just need the client ID, right? Yeah. Yep. Okay. So you have P1 game selected choice is equal to reconnect to game. Then, so we need to load it. So let's do that. Well, which one do we do first? Do we do game ID, client ID, or do we do local or remote first? Let's think about this for a second. If we did, I think we would get the client ID. We could select all three of them, right? We could do execute many and then select all three of them, just like we add them. We could select all three of them, and I guess we'll select them one by one just in case they don't exist for whatever reason. Just in case they like don't exist, one of them doesn't exist, it would throw an error or whatever. But, well, since they're all committed at the same time, then that means if one of them existed, all three of them would exist, right? I mean, isn't that how the database works? It's atomic, meaning that it's either all or nothing. Yeah, I think so. I know this seems like what are we waiting for, but that's actually a delicate thing. Yeah, so like, yeah, I would say if they're atomically added, then they should be atomically selected. Which means if one existed, then all three would exist. We wouldn't have to save the game ID because we already have it saved. And then if we're using a checkpoint system, yeah, then we have to get the checkpoint ID from the save file. Okay. And that's something that we haven't worked on yet, but we will be. Well, we haven't like actually implemented it, but we're getting there. We wouldn't need to get received client from the server since we would already have received it previously. We would instead assign it by loading from save file. Yeah, so we're just gonna say load all three. So we'll say load game ID, client ID, and started game or remote to, from DB since all three added to DB together. And I'll put this in parentheses. Since all three added to DB together, the atomic operation should be means if we have one, we have all three in DB. So we should get this each game ID from server side game specific terminal connect. Okay, get rid of that. Alright, so this would be where we did cursor dot execute, and then we're gonna say select from, we'll say select value from save data where object name is equal to, and then we'll put this, and then comma, and then we have to have an iterable, which would be the three object names. So we'll say object name iterable a tuple, and that would contain, do it in, do client ID, game ID, and then game serialized. Well, we don't want to save it in terms of serialized. I just realized that we would want to save it in terms of we would save it in terms of let's see, game local or remote, not serialized, game local or remote. So just like this. Serialized client ID, game ID, serialized game ID, game local, serialized game local. Hello? Alright, I'm coming. I had to do something. But all right, let's go ahead and wrap this up here. All right, so if we live select reconnect a game. In this case, we wouldn't. What line did I just add? I was adding in a line. Let's see. Okay, yeah, we want it to be game local or remote, not serialized game local or remote. And then we say load game. Yeah, here we go. Object name iterable, and then we're gonna do the 3 names, which would be client ID, and then game ID, and then game local or remote. There we go. And then we're gonna pass in the object name iterable there. And there we go. Object name iterable. Cursor execute select value from iterable. This is an attempt to iterate each object name, grabbing associated value. Well, we had to execute many, that's right. We execute many, and then we would do client ID equals cursor fetch 1, and then at index 0 yeah, and then we would just do it again. It's like a queue, right? Once you like fetch one piece of data to execute many, you selected all 3 of them, right? In order. So if you it's like a queue, I think. So it's where if you fetched one and the first one from the execute many that was fetched was client ID, and that means client ID would be associated with fetch 1, and then if you did it again, it would fetch the game ID, if I understand. I might be misunderstanding how this works. And then we would say game started game local or remote. Actually, what it's called. Change this to be. But you know what? We'll just let this be game local or remote. We could just say local or remote. Yeah, we'll just say local or remote. Let's change this. This would just be Yeah, but I don't know if this is right. Let me ask ChatGPT about this. The issue in your code arises because you're passing object name iterable directly to many function, but XQMany is designed to execute the same query multiple parameters. So you should be using a loop to execute individual queries for each item in the object. Will use fetch all after executing a single query to get all results at once. Flip over. Virtually using select where object name to fetch all results. If you prefer to run a single query to fetch all the values at once, you can modify the query to use the in operator. Okay, yeah, that's right. It's select value from save data where object name is in. And you do format join. So then you do 1, 2, 3. To use placeholders, you would do where object name is equal to 1, where object name in, let me say 1, 2, and then 3. Object name iterable. Select value from save data where object name is in, boom, boom, boom. Isn't this the same way that we do this for execute many? Let's see, execute many. We have tuple. Say insert into save data. Well, that's not the only place we do execute many. Here we go. Users data. It's a list. We say insert into users blank 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 users data. That's not the same thing. The select all. Alright, I think I'm gonna stop right here. Yeah, I'm done. Here. So execute value from say the object name is yeah, so we need to check this. Yeah, we have to test this. 370 in client refactor. Two hours 17 plus 29 is 46, right? 39. 29 and 17 is 46. So that's 2 hours 6 minutes, so 2.75. Okay. So now we're in the root of the project directory. We're gonna do git branch, see what branch we're on. And we're gonna do git add, git commit dash m. That in. So we committed. Okay. Now we're gonna do git push Canasta secondary. Alright, there we go. It pushed. Now let's go ahead and local. Copy this. Go to backup, delete the old one. Now we're gonna paste in the new one. And then we're gonna check it. So we're gonna go to text, devlog, all the way to the end. Yep, there you go. Yep. Alright, so that's correct. We gotta back out and rename this to reflect the date of the time we last updated it, which was today. So there you go.